Hi, welcome to the Bookman's Corner. I'm your host, Lois Lindstrom. Today we have an author who is a 4-time travel journalism winner and a climate change activist who founded the Chesapeake Climate Action Network. He serves as its executive director, where he has led local, state, and national campaigns for clean energy. We're happy to welcome our guest author, Mike Tidwell, to the Bookman's Corner. Glad you're here, Mike.
It is so great to be here.
Mike Tidwell is the author of our featured book, The Lost Trees of Willow Avenue, a story of climate and hope on one American street. His books include Bayou Farewell, about the disappearing wetlands in South Louisiana. In his latest book, Mike Tidwell shows how climate change is unfolding in his backyard in Maryland as he and his neighbors lose giant oak trees which they desperately try to save. So Mike, what inspired you to write your book, The Lost Trees of Willow Avenue?
Well, it started in 2022 when I began to realize that so many of the oldest trees on my block in Tacoma Park, Maryland, had died just in the last 5 years. We had lost a 150-year-old red oak, a couple of 3-century-year-old white oaks, and it wasn't me saying it was climate change. It was the city arborist who said it was because of extreme weather related to climate change. And the city public works department. And so I was just really curious as a climate activist. I wanted to learn exactly how was climate change affecting big trees in my neighborhood and on my block. Turns out it was a very interesting story. And so I wrote the book as a kind of additional alarm to get the public focused on climate change, making the point that climate change has gotten so bad that you could take a spinning lacquered globe and throw a dart at it, and wherever that dart lands in the world, you can write about the significant impacts of climate change there, whether it's Japan, South Africa, or the 7100 block of Willow Avenue.
It's incredible. It's incredible how it affects the trees. And that's my next question. How exactly is climate change killing the big oaks in your neck of the woods in Tacoma Park?
Well, it started in 2018. We had a record rain year in the mid-Atlantic because of
I remember that, yes.
Yeah, the jet stream wobbled, went down to the Gulf of Mexico, brought all this moisture to the mid-Atlantic. We set records in every mid-Atlantic state for rainfall. It triggered a mold in the soil across the region called Phytophthora, which translates from Greek to plant destroyer, which gravitated to the fine root tips, especially of older oak trees, stressed them out so much that it led to beetle infestation. But basically, the jet stream wobbling because of climate change resulted in beetles killing oak trees, and that was a big part of it.
So Mike, how many big trees were actually killed by climate change in your neighborhood?
Yeah, we lost 1,200 really big trees between middle 2019 and middle of 2021.
A lot of trees.
Just from the beetles, and we've lost 45 acres of tree canopy just since 2019. So it's climate change in various ways is disrupted. This one arborist told me that our native trees in this region are no longer native. We've changed the climate, so these trees are now foreigners. So we shouldn't be surprised that they're getting sick and dying. One question I have, if our native trees are foreigners, what does that make us as human beings?
That's right.
With climate change? We might want to accelerate our efforts.
Exactly, we might. What is the connection between human health and climate change?
So that's a great question. I mean, one thing in my neighborhood, the warmer winters mean that fewer ticks are being killed off by cold weather. So there are more ticks in my neighborhood. Throughout the region, there are more ticks, which leads to more Lyme disease. Also trees, the trees, people are familiar with this concept of forest bathing, Japanese concept from trees. Trees lower our stress levels. They give us a sense of well-being. They actually boost our immune system. They lower our cortisol levels. So I write in the book that and also hospital patients who can see a tree through a window recover faster, according to studies, than those who can't see a tree. So I write in the book, if trees help our health, what happens when they start to disappear? I think it means, yes, more people are getting Lyme disease, more people are getting infectious diseases because our immune systems are down, and also our spiritual well-being has been affected.
Yes, but also the deer, the ticks come from the deer, and there are a lot more deer now in places like Tacoma Park and all around the mid-Atlantic states, I believe.
Yeah, and the deer don't carry Lyme disease in their blood, but they're like a rideshare service for the ticks. They spread the ticks everywhere, so the deer amplify this profusion of ticks that are affecting people. I've suffered from persistent Lyme disease for over 15 years. I mean, I treat it with antibiotics and acupuncture, but I found in the course of writing this book that 3 other people on my block had Lyme disease, 6 members of my church had Lyme, a Boy Scout, an Eagle Scout in the local Boy Scout troop was bedridden for 2 years.
And that's all documented in your book. I was amazed. And then, the other thing is clean energy is under attack. Even when it's booming as tax credits for clean electricity generation and manufacturing are set to vanish. I mean, what's your take on that?
Well, I will say that the clean energy revolution worldwide cannot be stopped. Okay. Yes, it can be slowed down by the current White House, but worldwide, every day, human beings deploy 1 gigawatt of solar every day. That's the equivalent of a large nuclear power plant of solar power every single day, day after day. That's happening outside the United States. Also, the largest automobile market in the world is in China, where half the cars sold in China this year will be electric. So this revolution is happening all over the world. It's not going to stop. Fossil fuels have no future, but we have to accelerate that transition. And then you have the blue states in this country, California, Maryland, even Virginia is moving fast. One of the largest wind farms, the largest wind farm in the country, is being built off the coast of Virginia as we speak.
Well, also there are many climate change deniers who say there's always been climate change and we don't need to get worried now and spend a lot of money changing things. I mean, what is your response to these people?
It's true that the climate has always been changing due to the fact that the Earth wobbles on its axis and other issues, but we're driving this climate change. We know that because of our use of oil, coal, and natural gas, we've saturated the atmosphere with carbon dioxide, which traps heat. It's like a blanket around the planet. So we're driving this climate change, and climate change is not good for us. Sea level rise will cost my state of Maryland $27 billion in the next few decades. This is painful. This is not good for human health, and we should solve it.
Who is Professor Nin Zeng, a professor of climate change at the University of Maryland, and what is his role in your book?
Well, Nin Zeng, yes, he's a professor at University of Maryland. He is trying to solve climate change by sequestering the carbon inside of trees in the ground. He has noticed and documented that more and more trees are dying because of climate change in the mid-Atlantic. He wants to capture those trees instead of having them sent to landfills or wood chip for playground cover or incinerated in trash incinerators where their carbon is then vented directly to the atmosphere and becomes part of the problem. He wants to bury these trees in low oxygen soil, in clay, in farmland around Baltimore, Washington, Northern Virginia, to keep that carbon locked in the soil so it doesn't transfer to the atmosphere. It's called negative emissions or reverse coal. And in the book, I follow him as he tries to cut through government red tape, negotiate with farmers, and bury trees.
Yes. Well, I think this is a good time to tell our viewers exactly what is climate change? What is a definition of climate change so they can understand why the carbon is so bad? To tell us about what is climate change actually?
Yeah, when you burn oil, coal, and natural gas, one byproduct is an odorless, invisible gas called carbon dioxide, which migrates to the atmosphere, stays up there for over a century, and again traps heat.
It traps heat.
It traps heat,
and so it's like that's why the globe gets warmer.
Yes. Yeah.
Okay.
Infrared heat from the planet naturally radiates off the planet. In prior years, it would just radiate into space, but this carbon dioxide blanket traps it in the Earth's atmosphere, which means our oceans are warmer, our oceans are rising, we have extreme weather all over the world, and that's the basic physics. But if we get off of fossil fuels, we stop emitting more carbon, and we eventually absorb some of that CO2 that's in the atmosphere through efforts like Nin Zeng's effort, then we can lower the planet's temperature.
So what is so great is that trees help to absorb the carbon, right? And do oceans help to absorb the carbon?
Yeah, first of all, trees are just remarkable creatures. I write in the book how in the past we sort of perceive trees as these static, silent life forms. In fact, they're very dynamic. They communicate underground and above ground with each other. Parent trees like to be near their offspring to take care of them. They feel pain. They can tell time. They sleep. Trees are amazing. And one of the things they do is they absorb CO2.
They absorb it
into their trunks.
How much of it? How much do they absorb, you think? 30%, 20%?
Of the if you take trees, well, the oceans themselves absorb nearly half of all the CO2 that we put into the atmosphere. Trees absorb, I think, 10 to 20% of that traditionally, and plants worldwide even more. But what we're finding is there's so many trees dying, not just here in the mid-Atlantic, but in Canada, but around the world, so that trees, instead of being a carbon sink, where the carbon sinks into the forest and stays there, trees are burning and they're dying and they're becoming a carbon emitter, a net emitter. So that's part of the terrifying feedback loop that's happening just because of the impacts of climate change on trees.
Yes, yes. General Motors went all in on producing electric cars, but now the automaker is pushing to reverse California's EV mandate to only drive electric cars by 2035. I mean, do you think electric cars have a positive future in the United States right now?
Electric cars are the future of cars, period. Like I said, worldwide, their sales are through the roof. China, half of all cars sold this year will be electric. California has the right to mandate that all cars after 2035 sold in the state be electric. They're going to win in court from these challenges from Detroit and the White House. Right now in China, there's an electric car that costs $28,000, can get 300 miles of range, and can charge in 5 minutes.
Whoa.
That technology exists. That is disruptive. If anything has ever disrupted car technology, it's that. We can't keep those cars out of the country. We can't keep that technology out of this country. People want them.
So when you hop into your car and it's powered by gas, you're emitting CO2 all the way to the grocery store. That CO2 migrates to the atmosphere and traps heat for a very long time. Why is it so difficult to suck that same CO2 out of the air and store it safely somewhere on the Earth?
Yeah, you know, our best climate scientists have been saying since the year 2014 that we've been so slow in the conversion to clean energy. It's happening all over the world, as I mentioned, but we've been slow to start. As a result, we've overshot the safe level of CO2 in the atmosphere. The only safe level is 350 parts per million. We're at 425 right now, which is why the planet is warming so much. So the goal is to suck some of that CO2. We're in overshoot. We've overshot the safe level, suck that CO2 out of the atmosphere. It's expensive. I mean, you can build giant machines that have fans and filters that will absorb that CO2, but they use as much energy as they're helpful. You can weatherize rocks. You can bust up rocks like basalt that bind with CO2. It's just expensive, and we haven't figured out a cheap way to do it yet. You can plant trees, but we need an area the size of China to plant enough trees, and that's why we've got to work on that part of the equation, the negative emissions, and we also have to consider reflecting sunlight away from the planet.
Absolutely, absolutely. Now tell us about the 500-year storm when nearly 5 inches of rain fell in an hour on Willow Avenue in Tacoma Park. Explain the damage. What happened then?
Yeah, well, that flood where we had 5 inches of rain in 1 hour in Tacoma Park was in 2020, actually.
Okay.
And the water just flooded my church, flooded all kinds of, lots and lots of homes in Tacoma Park. What it did was it did a lot of damage to my church, Tacoma Park Presbyterian Church. Clearly triggered by extreme weather linked to climate change. The church said, look, our boiler room was destroyed. We had water in our preschool in the basement. They asked the city of Tacoma Park, you got to help us, you got to protect us. So the city of Tacoma Park busted up a perfectly good sidewalk on half a block outside my church, brought in 30 tons of soil, elevated the sidewalk, repaved it, not because we needed a new sidewalk, but that serves as a flood berm. It's actually like a flood levee to keep my church dry in the face of bigger and bigger storms. Cost the city of Tacoma Park $45,000, but that's climate adaptation. That's happening right now.
Everywhere, I guess, right? And have you had another storm as bad since then?
We have not, but one of the things I talk about in the book is the cascading impacts of climate change. So not only are we getting bigger rainstorms, that's happening in areas around the world, but as those same rainstorms kill our trees, those trees, big trees are the best thing you can have to ward off floods.
Right.
Because the roots absorb water, the canopies, a billion leaves slow down the rainfall. As those big trees die, even more rain flows toward places like my church. So we have these compounding impacts.
More flooding, yeah.
Yeah,
more
again,
flooding.
that's, I think, one of the original things about my book, The Lost Trees of Willow Avenue, is that it's the first book to look at one neighborhood.
Yes.
And the impacts of climate change. And it turns out it's not just one impact. It's not just trees dying. It's not just Lyme disease. It's the compounding impact. When trees die, you get even more flooding because those trees aren't there to absorb the rainfall.
Yes. Well, one of the things I want to ask, in terms of your Chesapeake Climate Action Network, which is a very prominent American conservation organization, what actions is this group taking to address climate change?
Well, Chesapeake Climate Action Network is dedicated first and foremost to clean energy solutions to global warming in Maryland, Virginia, and DC, and also on Capitol Hill. So we run clean energy campaigns at the state houses, city councils, to incentivize wind and solar power, electric vehicles. We also more and more are encouraging and supportive of research into how to achieve negative emissions, how to get carbon out of the atmosphere, and how to reflect sunlight.
So have you actually impacted legislation that's going through the State House, or have you actually had an impact like that?
Yes, I mean, we worked really hard on the Virginia Clean Economy Act, which incentivized, among other things, in a bill that passed in 2020, the wind farm that's being built off the coast of Virginia Beach right now by Dominion Energy. That was a consequence of legislation that incentivized that kind of energy over dirty fossil fuels. And we've had similar bills in local DC government and in Maryland.
Very cool, very cool. So you wrote that there are approximately 3 trillion living trees on the planet today, and there's enough land to plant 1 trillion more trees. And then trees sequester nearly a third of the carbon emissions we pump into the atmosphere. So how can we convince the public that we need to plant more trees?
Yeah, I mean, that's happening. I mean, there are tree planting campaigns that have been successful around the world, in Africa and China, in my neighborhood, and throughout the Washington, D.C. region.
Well, modern life depends right now on electric power for transportation and farming and industrial uses. And many political leaders say that clean energy is not going to replace fossil fuel because we can't produce enough of it for our needs. I mean, I think that's the worry, is that we cannot get enough going quickly enough. I mean, how do we get it going faster?
Well, we do need to get faster, but the idea that we can't switch entirely to carbon-free energy just isn't true. You see countries like Denmark that get half of their national electricity from wind.
But there's a much smaller country.
Kansas gets, I think, 30 to 40% of its electricity from wind power now. California gets so much energy from solar right now, and a combination of utility scale battery storage and solar, that gas use has dropped 40% in California in the last 2 years alone. So this is doable. We have to commit, especially solar. I think we underappreciate how disruptive solar technology is around the world. This is so cheap and so reliable.
We're having more floods and we're having more fires, and why is that happening?
Well, first of all, we're a water planet. We're mostly ocean. I don't understand why we're called Earth. We should be called water for this planet. And as the planet warms, it's evaporating more of that ocean surface.
Okay.
So more and more moisture is going into the atmosphere. The atmosphere can hold more moisture when it's warmer, but sooner or later that moisture has to come down, and it's coming down in bursts, where science is showing us that it comes down in extreme events more frequently. So that's why we're seeing more flooding flooding. Wildfires, places that are wet on the planet are getting wetter. Places that are dry are getting drier. So some of our temperate forests are just drying out.
Okay.
And they're catching on fire from the heat. And so that's why climate change is triggering both floods and droughts, both flooding and forest fires.
Yeah, well, it's a very good response to my question. And then you wrote that Mount Pinatubo was the massive volcano eruption in the Philippines in 1991, and it spread ash and dust and 20 million tons of sulfur dioxide into the atmosphere, and the average temperature dropped by 1 degree for a year around the world because the sulfur was blocking the rays of the sun. So is that something that scientists are considering using, ways to block the sun, right?
Yeah, volcanoes naturally cool the planet temporarily. Mount Pinatubo, which you referenced in 1991, was a massive explosion, and it sent enough sulfur dioxide, naturally produced by volcanoes, into the stratosphere, and sulfur has the quality of reflecting sunlight. So for 1 full year, Mount Pinatubo by itself cooled the entire Earth by more than 1 degree Fahrenheit.
Okay.
It erased 100 years of global warming prior to 1991 with one explosion. So the question is, can human beings become a human volcano? Could we put that sulfur in a limited way into the stratosphere temporarily to cool the planet as we get off of fossil fuels?
But I think it's probably tricky because you're dealing with all these various governments around the world, and trying to get cooperation from all of them is a little bit tough, isn't it?
I think it is tough. We do need cooperation of all the world's governments, but as all the world's nations suffer more and more from the wildfires, from the droughts, from sea level rise, I think you'll see more and more conversation and more agreement that this is something we need to study and maybe, who knows, eventually deploy.
I found it fascinating in reading your book that you visited NASA's Goddard Space Flight Center with Dr. Ning and toured Building 33, which houses the greatest Earth scientists in the world. What did you learn about Greenland on that trip?
Yeah, so NASA Goddard, which is in Greenbelt, Maryland, right outside of D.C., does house one of the greatest concentration of Earth scientists, people who study the oceans, study our forests, study the atmosphere. And while I was there at Building 33, there was a display of satellite data studying a glacier system in Greenland. And it shows satellite photography from the year 2000 to the year 2021, and it just shows the degradation of that glacier from warming and the disintegration, and more that glacier is melting and also accelerating the flow of the remaining ice to the ocean, and that's land-based ice. And as that ice melts or lands into the ocean, it raises sea surface levels all over the world, and so we could get considerable sea level rise just from this one part of Greenland. And this is all on display. It's photography. If you believe that human beings can put satellites into orbit, and if you believe we could put cameras on those satellites, then you have to believe the photograph results that we see.
And where can you see those photographs? You'd have to visit
They're on the NASA website.
On the NASA website right now. You can see them. Incredible. It was also interesting to read about your trip to NASA in Maryland, because you also learned about AeroNet, which is a set of robots that are based around the world. How are these robots deployed, and what do they do?
So AeroNet is a part of NASA that just monitors aerosols in the atmosphere. So aerosols are anything that can reflect sunlight. It's any kind of gas or substance that can reflect sunlight. So that can be smoke, that can be sulfur dioxide from volcanoes, it can be pollutants from burning with fossil fuels. And so they monitor that. And the reason they do it is to have a way of confirming satellite images. So you have satellites that are taking photographs from outer space of the planet Earth. But in order to have a really accurate view of what they're seeing, we need to know how much aerosols are in the atmosphere that might disrupt that photography. So AeroNet provides data that, combined with satellite data, gives us a more accurate view of the Earth. So they're basically just measuring aerosols. They're measuring substances that act to cool the planet by blocking sunlight.
Amazing, amazing. And these robots are all around the world.
All over the world, gathering data by looking at the sun and then looking into the atmosphere, back at the sun, and measuring these results.
And it's amazing. In 2023, there were very dry conditions in Western Canada, which meant that 2 million acres of mature forests were ablaze in Alberta and British Columbia. There were also wildfires in eastern Canada. Do you recall this?
Oh yeah, I write about it in my book. Anyone who lives on the East Coast remembers the summer of 2023 because, as you said, it started with Western Canadian wildfires that burned so hot that the heat from that fire sent the smoke all the way to the upper atmosphere, and it traveled over the East Coast. We weren't breathing it, but it was the sky was hazy. It made for spectacular sunsets.
Yes.
But it blocked enough sunlight in the spring of 2023 that it did give us a cool month of May.
Yes.
So this was forest fires cooling part of the planet. Then in June of 2023, we had wildfires in eastern Canada, also connected to climate change. That was more low-level smoke that we actually breathed. Washington, D.C. on June 8th, 2023 had the worst air quality of any city in the world.
Amazing.
Again, these are the consequences of climate change, and I write about how people on my block, again, my book, The Lost Trees of Willow Avenue, is about climate change on my block, how we struggle with that air quality.
Yes, because people could barely breathe, right?
Yes.
They couldn't take a walk. What I love about your book is a story of climate and hope on one American street. Now, why is hope in your subtitle?
Well, first of all, I think people have to have hope. I mean, I'm a hopeful person, even though I'm a climate activist. We fight uphill against some really powerful special interests in the oil and gas and coal industry, but we've had our successes. You know, like I said, solar deployment around the world is astonishing, 1 gigawatt every day. But we have to do more. So I'm confident that the clean energy revolution is going to survive the current administration. The cost of clean energy is going to continue to drop. The attractiveness and the lower cost of electric cars are going to be what people choose based on cost all over the world. And also, I believe in human beings. I believe in humankind. And I think that we can and we will come together to solve this problem.
It's been great talking to you. And I want you to tell our viewers where they can find your book to purchase it.
Yeah, well, this book is available wherever books are found. So your local bookstore right now or Amazon. You can also listen to it on Audible.
Oh, good.
And you can actually get a signed copy with the proceeds benefiting my nonprofit, the Chesapeake Climate Action Network, by going to ChesapeakeClimate.org.
Wonderful, wonderful. Well, I hope people will read it and take action. Thank you again for being a guest on the Bookman's Corner.
Lois, it's been a pleasure.
Thank you. And thank you for watching. Please join us again next month for a new edition of the Bookman's Corner. I'm Lois Lindstrom.